All right. Hello, everyone. This is Akanksha Jain. I work in software product management side at ARM. I look into the software enablement story for Linux kernel and FreeBSD. And today we are going to talk about FreeBSD enablement on arm64. So let's go through the agenda. So we have architectural feature landing pages. That's the usual housekeeping. What's the context and scope of today's discussion? A little sneak peek into FreeBSD. If you already know about it, feel free to ignore that page. Highlights, some more housekeeping in terms of FreeBSD landing pages. FreeBSD on ARM64, what's the journey like? Where did it begin and where are we now? If you have attended any previous kernel update sessions, we do pictorial representation of the software enablement story in flowers. And I've tried to do something similar for FreeBSD. Feel free to compare. The ongoing activities in terms of the development pipeline, what is a futuristic time window like, and of course, addressing the elephant in the room, why FreeBSD on ARM64 when we have Linux, and some more additional reading. So with that, let's get started. This is an architectural landing page on developer, which talks about the features and description. There is a hyperlink attached. Now, in terms of the context and highlights, does everyone know about FreeBSD here, its history, and any details? If yes, then this might not be very useful, but if not, I just wanted the audience to be more representative, and I have kept a few snippets. So FreeBSD completed 30 years in 2023, and there is a very detailed timeline on its landing page. Of course, I haven't captured all of it, but there are few milestones which are relevant even from ARM's perspective. So FreeBSD, as you all know, is an open source operating system which is Unix-like. It is architecture agnostic, standards compliant, and its USP lies in its stability, reliability, and performance. Now, where did this journey begin? We all know in 1969 there was Unix release, Unix was developed. Now this code license was taken by University of Berkeley to carry out research, and that was known as Berkeley Unix or Berkeley Software Distribution, hence BSD. If you look at the journey, in 1992, 386 BSD was created for Intel's i386. Now, it was felt that the development flow was slow for that, which led to the creation of the first FreeBSD release, which happened in November 1993. Now, with that, there was another milestone in the year 2000, which was with FreeBSD jails. Now, jails is a virtualization concept which allows the entire system to be broken down into a lot of mini systems or jails, hence the name. That also led to another milestone in 2008, which was addition of ZFS file system, because of which FreeBSD boasts of a robust protection against data corruption and efficient data compression. And that explains why FreeBSD is said to be reliable, secure, and performant. Then in 2012, we all know University of Cambridge started an initiative around Cherry project on Morello boards. We have more of this coming in the later slides, so I wouldn't talk much here. In 2012, FreeBSD migrated from GCC to Clang. In 2015 is when we more proactively engaged in terms of FreeBSD porting to ARM64, which was then promoted to Tier 1 support in 2021. That year also saw migration of the SVN repository for FreeBSD to Git. Now, this is a little about the history. If you're more interested into a deep dive, there is a 30-year journey, and I have attached a hyperlink for that. Let's look at what a development workflow looks like. There are similarities with Linux. So similar to how we have patches on list, in FreeBSD, we put the patches on Fabricator, which is then discussed in the community. So you have a community review, which is roughly about a month's time. and then it is merged to the main repository, which is also known as current branch. So it's like similar to a development flavor, like how you have in SUSE for Tumbleweed or Fedora for Red Hat. And then you have a month of rigorous feature testing, after which the features are merged to stable. And then from stable, you have minor releases that are branched out every 6 to 12 months. Now, what's the cadence like? So the major release or the stable is supported for 5 years. And you have a minor release which is supported for 3 months after the next release. So for example, if you have a 13.2 release, that would be supported for 13.3 plus 3 months. So if you do the math of 6 to 12 months of a typical cycle for a minor release to be announced, and you have 5 years of major release, that roughly comes to 5 minor releases, which kind of matches with the historical data of FreeBSD release. So you have 1 major release and 4 to 5 minor releases. There are also alpha versions, which are snapshots. So you have a weekly cadence for that are branched out of the main as well as the stable repository. You have beta or release candidates similar to how you have in the Linux kernel cycle, again with a weekly cadence. There is more detail about release 14 schedule, which is the current FreeBSD release. And if you fancy more about what these releases are, what's the history, there is a detailed page which I've attached here as a deep dive. So one thing about FreeBSD is there is extensive documentation about everything. So everything is defined to the T. All right, that was a little about the context and highlights. Let's see a few more housekeeping pages. So if you're new to FreeBSD, there is a how-to page on how to contribute. I've also attached an image, which is probably not very legible here, but how you create a fabricator diff view, how do those patches appear on the maintainer's side, and a few more housekeeping. So if you want to understand how to port FreeBSD on ARM, there's a landing page for that. If you want to know about generic FreeBSD mailing list, so that's architecture agnostic, you have all architectures there. If you want something specific for ARM, that's there as well. The release history, which talks about the cadence, the announced dates, what's the hardware compatibility list like, etc. Upcoming events in terms of conferences, and Cherry project that I was talking about. So we have on FreeBSD side, of course, in collaboration with University of Cambridge, successfully ported Cherry BSD, which is a derivative to FreeBSD last year. And there's a landing page here. You can download details from that. Now, FreeBSD on arm64. Of course, I'll come to why on arm64 in a bit. But any guesses how long this association has been? Any numbers that come to your mind? One hint, this is not recent. I'm sorry? No? I won't penalize. Come on, a number.
73.
No, that's too ambitious, no. Okay, it's 10 years. So 2024, we complete 10 years. Now, before I dive deeper here, if you're expecting cake and wine celebration for this, like other projects, blame Andrew Waffer, because I suggested and he said, let's go the healthy way, so we have just water on the house. All right, let's look at the timeline. So technically, it did begin in 2012 with the Sandbox initiative, and then that led to integration of the early boot code in FreeBSD repository. That was in 2014. With that, in 2015 was a more proactive engagement. So ARM collaborated with the FreeBSD Foundation and Cavium for ThunderX to get the initial FreeBSD support ported for ARM64. With that, we also had ARM64 support, which was imported into the repository. Now, in the next window between 2015 and 2021, we were working on operating system improvements around 4-level page table support to increase the size of virtual memory, non-coherent device support. Then improvements to the PCI driver, super page support, which is equivalent to transparent use pages in Linux, interrupt handling for generic framework, initial ACPI support, Cortex string library for faster memory, AES instruction, of course, for cryptographic scope, and PSCI and SMP multi-core support. With that, in 2021-22, we focused more on enhanced architecture support. So we were looking at beginning feature parity with Linux. And for that, we started with an initial enablement around BTI, RAS, pointer authentication, common not private support, 16K paid support for improved performance management. And this is also endorsed by Netflix. Performance and security improvements, and adding FreeBSD support for ARM into LLVM tools. This is also the year, as I mentioned, where arm64 support was promoted to Tier 1, so it is a significant milestone. Now, with all this, where are we now? So we all know there has been news about a lot of OEMs entering or re-entering the market into laptop market segment, PC segment, and FreeBSD looks at leveraging that on ARM64. So there could be possibility that we diversify from the server market to also laptops, gaming, or perhaps automotive. That's possible. So while we would continue to work on feature parity with Linux and on virtualization support. So Beehive, as you see, for those who don't know, Beehive is the hypervisor in FreeBSD. So we would intend to work on that in the near-term window. But more in terms of futuristic window, we also plan to engage on standards adoption, telemetry support. More of this I'll cover in the next slides. Enhanced virtualization support, memory performance, errata workarounds, and of course, with all this, we also intend to engage more proactively with the ecosystem to move the needle from awareness to adoption. Now, this is the flower slide which I was talking about. Of course, it is no match to the Linux slides, but we are getting there. If you see 8.1, that's more or less done. 8.2 is what we are actively looking into, and then few features which have been cherry-picked on 8.3 and 8.4. But hopefully, the next time we present this, there should be more greens and less of reds. All right, now what's happening in terms of the development pipeline? So in terms of ongoing development, we have statistical profiling extension, that's SPE, for which we have finished investigation work. Now for this, there are two modes of feature support. One is the single CPU, for which we have finished the prototyping. It's in final stages of cleanup, so hopefully this should expedite the upstream merge into the FreeBSD kernel. And then you have the single thread between multiple CPUs, which is yet to be explored. On VAT support, we have the hypervisor support, which is work in progress, only after which we would be able to merge the in-kernel support, though the development for that has been done already. Then on SVE side, we have for 1.0 initial kernel patches under review, after which we would be picking up 2.0. In terms of the next steps on the roadmap in futuristic window, we have security extensions like memory tagging, which would be picked up. Large physical address 2, for which we have done the basic work, but we're looking for a use case around it, more in terms of hardware. And then a little on the system IP side for SMMU and PMU, we have the hypervisor support for Beehive on SMMU side and on guest OS side for PMU as well. Now, FreeBSD at ARM, why? And what do we have next? Of course, we discussed a bit of it in the development pipeline, but more in terms of the strategic need for this. Now, we do recognize that there is a very mature pipeline for Linux development, but it was also felt to have a healthy balance in the ecosystem. So while there is a Linux on ARM, we should also have a FreeBSD on ARM, which would make the ecosystem more representative and balanced. And this in no way is an advocacy that one distribution is better than the other. we would let you pick your poison, choose your demon, and we will help you train them. So whether it is Linux or FreeBSD, we are here to help you. Of course, we also recognized that if we look at diversifying the market segments or the business needs, there are no two needs that would be same. So you have different licensing needs that are around. There are product deliverables which would require partners to have proprietary software, and that's more favorable with a permissive license like BSD as opposed to the GPL license. So if that is one of your reasons for your business goals, this could fit the purpose. And of course, it is a flatter hierarchy, it's a smaller group, so the upstream enablement path is shorter, and that would be leveraged if you have a shorter time to market in the market. With that, what do we intend to do in the next few years or few cycles? Of course, in the short-term window, we would continue our work on feature parity. So we intend to reduce the architectural lag as much as possible on FreeBSD side. And once we have that, once we are at par, if there is a lot of use case around FreeBSD enablement from partners for their products, we also intend to leverage the fast upstream path to have features landing first into FreeBSD as more of a pilot test before we look at other operating systems. But of course, this cannot be a standalone effort. It has to be symbiotic. So if partners want to leverage that, we are up for it. And then right now, I don't know if you all know, but it has been primarily in all these 10 years, pretty much a one-man show with Mr. Andrew Turner doing the arm64 enablement. We intend to grow this team size organically. But with that, we would also want to diversify the market segment for strategic growth. So like I mentioned, beyond HPC and standard servers, be it laptop, be it gaming, or automotive segment, we intend to pivot into that. And this, again, has to be a mutual effort to co-create growth. None of this is actually possible. One bottleneck that we feel is a strong use case. So while we do the feature parity and the enablement, that is not possible to be run in the direction of travel we intend to unless it is strengthened by use case in the partner ecosystem. So help us help you. And with that, if you have any ideas on strategic insight, you have any better ways of doing this, any business ideas, feel free to collaborate with us on the learning path. There is landing page for that. And we sincerely want to engage, not just in terms of feature enablement story, but also to understand what your business needs are and to help you adopt FreeBSD enablement on ARM64. With that, I'll come to the last slide, few more resources. Now there is an ARM64 platform support list, which I appreciate is not very exhaustive, but it is a list of platforms that are supported by FreeBSD, a few more housekeeping, and a few patches of interest around the partner system, ecosystem engagement from these partners. Then there is a developer landing page and a few conferences coming up. So that's about it from my side. I was hoping to be joined by Andrew Waffa. So if you have anything good to say about me, I'll take it. If there's anything negative, I'll pass it to Waffa sincerely.
Okay, this one looks like works. I used FreeBSD in my SBSA reference platform testing, and I have to say that I used NetBSD, OpenBSD, and FreeBSD for testing, and FreeBSD community is the best of those three to cooperate with. They have normal bug tracker, they backport fixes between releases, and they react quite lively on IRC when the issues came, and you you tell about the issue, you report, etc., they really cooperate.
Thanks for that.
So I see some company names there. I mean, do they have production environments running on arm64 already? Do you know?
A few of them, yes. Yeah, there are more details on those patches. Yes, there are, definitely.
Where do I find platforms that currently run FreeBSD on arm64?
I think the first list should have that arm64 platform. So of course it would have InvenSTP and Juno, which are ARM boards, but it would also have partner platforms that we are supporting. So I hope you all spread the word, and next time we have at least as much population here as that for Linux. Yes. Yes, sure.
Okay, sorry. So I apologize for the stupid question, possibly, but you spoke about the reasons to choose FreeBSD over Linux. For example, you spoke about licensing.
Yeah, we suggested. Not spoke very strongly, but yes, go on.
So I'd be interested about more reasons, for example. So I'd be interested, where is the place of FreeBSD, really? Okay, we know the licensing is one of the things to choose it over Linux. What's other things, possibly? That's one question. And then the second one, you talked about the feature parity between FreeBSD on ARM and FreeBSD on x86-64. What would be the feature parity between FreeBSD and Linux? Again, similar question. What is the strongest points to choose FreeBSD over Linux in my application?
Right. I wouldn't get into, I'll measure my words because I'm also going to present Linux day after. So I do not want to say anything which comes across as a favor to FreeBSD. But in the public domain, we all have established facts that FreeBSD has a flatter hierarchy. So if you have patches on the list, from the lead time to see it in a kernel is going to be far longer for the same feature as what you would have in FreeBSD. So, which I said earlier, if you have time to market, which is very competitive, in that case, it would be an advantage. Also, there are times it's felt that the drivers, especially like there was one panel discussion where I heard that there were concerns from partners that when they look at an SoC, the drivers are not very well documented. It's not about ARM processor, but the peripherals that are used. And all those things are very widely covered in FreeBSD documentation, so that could be an advantage. And with licensing, yes, of course, it's a very big advantage because if you want to monetize your software with no strings attached, so you're not obligated to contribute back to the source code. So that is a very strong advantage. But having said that, it is more of creative freedom and design choice. So there isn't like ARM is saying that FreeBSD is better than Linux. It really depends on your business objectives. If it suits your purpose, FreeBSD, otherwise Linux is already up and running.
Okay, thank you.
Right. And for your feature parity, the flowers that I talked about, this is more in terms of parity with Linux. So this was not arm64 versus x86. This is more with Linux. But of course, like when we do that, we keep in mind parity with x86 as well. And if I have not convinced enough, like I said, I will sincerely relay to Wafa. He would answer.
Thank you.
All right, thank you. Yes.
Thank you. How easy is it to take a Linux driver and port it to FreeBSD? Let's take like an audio driver in ALSA. What would be like just low, medium, large effort?
I think it should be somewhere between low and medium. That's what I understand. Also, when I talked about the resource links, how to port FreeBSD on ARM, this has detailed breakdown of a lot of sections. So there are how-to sections, and of course, if you are struggling with something, we are happy to help.
Okay. Do you have like an ALSA-like framework in FreeBSD?
I wouldn't want to jump the gun on that. I believe there should be, but I can get back on that. I'll have to check with Andrew on that.
Okay, thank you.
Yes.
Simple answer, I think, is you need to rewrite the driver because you cannot copy the code.
Yeah.
Okay, so that's the first thing. But usually, I mean, I'm not a FreeBSD expert. I mean, I managed a team that ported FreeBSD to another architecture in a previous life, right, Leandro? And usually the architecture of the kernel in FreeBSD is much simpler. So it's easier to understand, easier to follow, the code and to implement drivers, for instance.
Thanks, Leonardo. I so wish Wafa was here. All right. Anyone else? Yeah, I wasn't expecting that many questions, to be honest.
Yeah, I was wondering if, even if it's just in the far future, there are plans for enabling FreeBSD on ARM to work as a confidential computing host using CCA, or as a confidential computing guest.
I first want to thank you for asking this, because when I was preparing the slides and I preempted this question, the team smirked it off saying, oh, come on, no one is going to ask about CCA. So now I know I was having a good intuition. Yes, it is definitely in the roadmap, in the future window. It's going to take time because even if you look at parity with Linux, which is far ahead, CCA is something, there are too many twists and turns in that story. You have specs which are maturing, you have sub-features, features that require larger discussion in the community, hardware availability. So there are a lot of caveats there. As soon as we have more clarity on all these things, and we also see, okay, what couldn't work in general for the development on Linux, which is progressing a little ahead. Like I said, we are trying to match up. We would learn from that and not reinvent the wheel. So that's the idea. So long story short, it's definitely in the pipeline, but it would be a little far ahead.
Cool, thank you.
Thank you. And now I'm going to keep a timer. No more questions. All right, thank you, everyone. Thank you.